Hello. So this is the next part of the talk, which is something that's been a long-awaited project in the works and been going on for several years now. So one of the interesting things about this project, when we started it, we thought no one cared. We didn't hear anybody ever saying anything about it when it started up. No noise. So we're like, are we just spinning our wheels? And then once I start seeing things land, I start getting emails and people saying, is it ready? Can we deploy it? And I said, no. So it actually is something actually wanted. It's one of those things that you threw out there and you said, hey, it's starting to become available. And people started to get riled up about it and said, wow, we do really want this. It's actually very funny. I believe that DOE requested this feature before I started working for the lab 15 years ago. That's how long this has been wanted. And but no one had ever had a chance to do it and work on it until just recently. And the big push for this is, you know, with the Linux native client work, when we were starting to talk with the kernel maintainers and saying, what do we need to do to get it in? One of the things Dave Miller said, you got to support IP version 6. So we started working on IP version 6. So the goal was so our main goal here now is that it is to support IP version 6, but the way the API is written, we can support lots of other APIs as well. That's up to quite a large size. One of the long desired things is GUIDs to be supported in InfiniBand. So we don't have to have set up IP anymore on our InfiniBand networks. So this is a nice thing. And as Andreas pointed out earlier, the protocol is expandable. So even though the size is about 20 bytes for the LNet configuration, the network packet layout, we can expand it up to much larger sizes without much change to the code, actually. So this work has actually been a collaboration between SUSE and ORNL. Neil initiated this and started doing it. And over time, I've been as we get to the finish line, I've been doing more and more of the work. Of course, I like to give thanks to like Chris Horn from HPE and all the LNet guys, like Sergey, who's been a great help looking over this work, testing it, and even developing some of the work for this project. And the goal was by 2.16 release. This is the foundational support for LNet with this is going to be complete. You know, you'll be able to do pretty much most of the more common features. There are a couple things that are still not complete. It's the things that are not critical for LNet, such things as the GSS stuff, and the complete no map. No map does support some of it, but it's not complete with what it could do, or some of the NRS stuff. We need to be able to have better support for large NIDs. So we have a ticket that was open in 2016 for this. So that gives you an idea. when it was requested, this is when it was officially requested in our JIRA. So, and as I was saying earlier, it was about the native client support with this. And it was in 2019 that we actually sat down and we hammered out the details, the low-level details of what the implementation would be. And the first landings for this was in 2013. So that's how long we're seeing the landings. The reason it's taken so long, as you probably know, is one is the changes are far reaching. Like LNet is in every subsystem in Lustre and all over the stack. It's a quite far reaching piece of work. It's probably one of the broadest aspects of the code base that you can touch. Change logs and everything, you wouldn't believe where it's located. So that's where we've been, and it's been a long ongoing process. So by 2.15 and the LTS, if you look through the code, all the internals are actually converted to this new API to support these large NIDs. It's just the external stuff wasn't done. We didn't support any of the user land tools or anything like that. So you can't do anything with it. We didn't actually transmit the large NIDs over the wire. Now we are. So So all that stuff was added in the last release. So where is it today? So all the basic functionality is done. So everything that you normally do to configure your LNet, your exports, your imports, you're adding your network interfaces, all completely different, all supported. So everything you would need to bring up your systems, it's supported. And they all take large NIDs, so you can do that. So what does it look like to you as the end user? It looks the same. The tools it's pretty transparent to you, what it is. Under the hood, it's very different, but internally it's quite the same. So it's just using your standard IPv6 string NIDs with the colon delimiters. Some of the, now underneath, as you know, there's LCuddle tool and there's LNet cuddle tool. And if you don't know the history of that, that's because cuddle tools were written to support network setup before multi-rail. And LNet cuddle tools was they rewrote all the ioctls to support multi-rail. So it was a rework. And so what we did is we looked and we said, oh no, we have to add another 100 ioctls because that's what it would amount to. We didn't do that, actually. In fact, the way I rewrote it, we actually unified both APIs. So underneath the hood, it's the same API being used for pre-multi-rail and multi-rail APIs. So it looks identical now. So it's pretty much done. There's a couple things missing, mostly for the test system. So we have things like net fault. We can inject failures into the network code to simulate. And there's a couple things like connections. There's details. It's very L&D specific. But those are the only things that are really missing. So those patches are actually, I have them, they exist. They've been pushed, some of them. They're going through the review process, but they're mainly for testing. And that's for the Sanity LNet test. Socket LND driver, completely done. Now the InfiniBand driver is in the works. So it mostly works because it uses TCP on the top. But when you get to the RDMA, it starts to send special packets with it. And recently we discovered, oh yeah, we have to do that. So that worked partially. The driver has been, there's the first set of patches going. The next one is going to be wire protocol patches, changes in the underlying code. So that way the InfiniBand, we just have to make sure that we don't break like 215 and start sending, IB version, different versions of those packets, and the client 215 doesn't know what to do and panics. So we have to be very careful with that. Now, one of the biggest changes that you will notice is, which impacts how the tools do behave. There are some changes though. So internally, we moved to Netlink for all our APIs from ioctls. So one of the advantages it gives you is very large setup support. So there are people like NASA who wanted to set up like over 10,000 routes in their configuration files. Before, you could never support that. We can. There is still a limit though. Please be gentle. It's like 27,000 routes you can set up in a single config. But yes, you can actually do these absurd large systems now. Before the ioctls, they would only do 64K. The other thing is that we did is we changed one of the things that LNet was famous for doing was it was changing its APIs constantly, its ioctl APIs, so that the tools would break after a couple of versions of Lustre. And if you try to run them, it could cause kernel panics and stuff like that. So I created an API for an unstable API. Actually, so what that means is that if you add kernel code in to support like new parts of your YAML configuration, the old tools will work, the new tools will work. You never have to rebuild them. They will just work forever. If new information comes, the tools will never recognize it. You never have to rebuild that. So if you add new tunables, you don't have to rebuild. You don't have to add new code to the userland code. It will just work magically. It's quite an interesting feature for that. The other thing is that the YAML handling is way more robust. Anyone who's done the LNet configs And if you do it out of order, or you do things like that, or you forget a field, it does breaks. It doesn't do that anymore. You can reorder your YAML config any way you want, and it configures the LNet packet, sends it up. It doesn't care what order it is. So it's way better than it used to be. And the last thing is also actually improve the error handling. So everyone who knows that you did your YAML config wrong and it just gave you this weird obtuse error, you can actually have Netlink send you proper errors down to you that says, well, you didn't really have the proper NID string. So it'll actually explain to you what you're doing wrong. Now, the behavior I kept is, and I debated about it, was that if you did a config, it still does the old behavior that if it does find something that it just can't work beyond, it'll stop there for setting it up. I did think about like going through the entire configuration and just avoiding the things that didn't work and then reporting those things as broken, but it would be hard to figure out where that error was. But it was an interesting idea, but it is a possibility to do it that way. So the good news is now that this is all set up, we are in a position to actually start testing this stuff in Malu. WAM Cloud is set up IPv6 addresses, and that was part of the hackathon. Someone is working on updating the test script so we can turn on the by default IPv6 and set up networks with it and test with it. So we are at that stage already. We are getting into the testing stage. So what is missing with this release? UDSP support. So that was missed and I didn't get to do that yet. It's something that's not critical. Like there's some people that use it, but it's not like you have to have it to set up your networks. So we thought, oh, we can do that. It's not something hard to do. I could probably write a patch in 3 or 4 days to support this. And it's actually interesting because UDSP, if you think about the structure of the file and how it's done, when it was originally proposed, I said it was kind of inflexible. Like we would love to see like various types of like configurations you could do that's currently supported, but we'll see that. Since the module config file is, I frown on it. It wasn't finished with large NID support. We could do it. I prefer everyone to use the configuration system with LNet Cuddle, but I know there are people who love to use that. So that needs to be finished, and that's actually tested in the tests. LNet self-test, there is a move to move it to YAML and to use YAML configuration files for LNet self-test. That has fallen to the wayside. I do want to get that to be work with large IP addresses. And there are actually some really cool improvements I've looked at doing, like running LNet self-test on a live network. So while you're in production, you could actually monitor the performance in real time while it's running. That would be really credible. And there have actually been some suggestions, like Tim Date told me, he said, you know, we already have the LNet health check and we have these separate counters. We could actually use the health check counters to actually see the state of LNet in real time. And of course, as we've been expanding and doing testing locally, and Chris Horn, we've found a few bugs. And actually there have been people like Stanford, I've noticed, has filed a few tickets with their testing the bleeding edge stuff. So we need to fix that before the release. So like one of the things was the restoring of host names with LNet Cuddle ping. That was a regression. There is a patch to support net devices for their events, for their state. So if you take down your IB device, the LNet layer will notice this and put that and say that is in an unhealthy state. Again, that work is done. It has to be reviewed and landed. And of course, as we just do more testing, we're going to discover some bugs. And then, of course, Lustre has its own thing with Is it the string? Yes, that is actually what you can mount with now. Yes, it actually works. You can do your IPv6 address. The failover nodes also support it. So And we can handle the strings a bit better. That was worked on for this. Also, node map. We did add basic support for large NIDs. The only problem, there's only support of one NID per node mask for configuration right now. So you have to add each NID at a time. I know there's no ranges, so we want to add net mask. But it's a touchy thing to do. I realize that if you misconfigure one number in the net mask, you'll end up going from, your 20 NIDs to 100,000 NIDs in your NID range. And I don't think anybody wants to install that many. And of course, we also support, if you look at all your hashes and stuff in your debug FS, you'll notice that we're using it. The UUIDs also support the large NIDs. There has been report, but I have not seen it yet, that it could overflow the OBD UUID. It can be too large, but I've not run into it. The tendency, I think the problem is usually the tendency, I don't know if you're familiar with IP, you probably are, with IPv6 addressing. Usually they tend to do the short format and they compress it. So usually it fits. So you have to get like this address that like fully expands, and that doesn't happen actually too often. I found that out. It's kind of hard to do that. So what do we need left? So probably the biggest work is the support of IPv6 netmask. So we had that discussion, and we said instead of doing IP ranges, it would be better to do a net mask, because that's usually what administrators are used to when dealing with IP addresses. It's needed on both the kernel and user land side. And this is going to impact, and once this work is done, we can update the root squash handling, the node map stuff, the mount strings, and NRS TBF. There's also changelog support. So changelogs report IP addresses. There is a patch, and I have the patch working. The only thing is I need to work the patch. So here's the thing with Lustre. If you ever want work done, you can't just do work. You have to add a little extra, something extra to make it worthwhile to land. And that's one of the things with that patch. There are some things we discovered with filtering of changelog at the user level that it doesn't work. You can't say, oh, I'm not interested in job IDs. If you try to turn that off, it blows up the application. So it didn't work properly. So I was like, all right, I'll fix that too. And of course, this is what will be completed before the 2.16 release. And the work slated for 2.17 is the GSS support and the SPTL RCP. We're going to have to support large NIDs there. And the other thing is the get identity thing for the, for when you run up your MDS and it comes up, and for all the mappings for your user IDs and things. So it does actually fetch NIDs. That should be supported. I was told that that's not as important because of node map and that. It's less of a requirement nowadays. So we just kind of let it slide, but just for the sake of completeness. So with all this work being completed, there are actually some nice new functionality that's been added that you will be interested in using. So one of the things that when you set up your LNet devices and you add a new net like TCP, and that you usually do it through your interface, right? Your network device, Etho0. Well, sometimes Etho0 has more than one IP address. So now you can actually specify the NID, specifically that NID, and it'll bring it up on that NID. It'll find that address out of there and it'll bring it up. And of course, the other thing that was completed in 2.16 was LNet discovery in the background. So that was some nice work that was added. And then, of course, we have some future work, some more advanced improvements. One of them is mapping host name at net type to many addresses. So I know that some people love this idea, and I've found some people really hate this idea. So, but the idea is that you could do your mount at your host, and it would translate to many IP addresses. and you could configure them. The same with ping. You could do an lcuddle ping on your host name. It'll translate to multiple NIDs. I think that we'll have to figure out how to do that. In some cases, that's useful, and in some cases, it's useful to return only one address, as some people pointed that out to me. The other one is using imperative logs for client-to-server connections. So we can use the logs instead of YAML configs to use an LNet discovery to bring this stuff up automatically. That's a nice feature. And then we want to be able to add a new network to a file system without write config. That would be a huge benefit. And that is essential for cloud support. And another thing requested was removing NIDs from config logs. That's also, it can, especially in cloud environments where NIDs, these addresses are rolling over. There's DHCP servers that are releasing these. This is very painful. That would be very painful on the change logs. And then the last other crazy thing, I just love cloud computing. We have a limitation of only 32 NIDs for the portal RPC connections at a time. I'm working on making that in any number. So people who want to start up hundreds of NIDs on their nodes and work it, you can. So that's the conclusion. So as you can see, most of it is complete. And so this was a nice short talk because there's not too many features to be added, a lot of reports. I just wanted to report how well the project has gone. And it will be completely feature, every little side feature. We're going to go searching for every NID possible functionality in Lustre during 2.17 and finish it. And of course, out of this is we're going to get some nice new functionality that people have been looking forward to. And then the big caveat, of course, is once this is all done, this is one of the big steps for upstream submission and completion for the native client. And of course, I want to thank everyone for the acknowledgement to DOE and also the people involved in the project. Any questions? Okay.
Kevin Harms, Argonne. So, James, what do IPv6 has been sort of coming for a long time, but there's people still struggle to deploy it in a lot of places. Once you've delivered IPv6, when do you think the first person will actually try to use it in production?
Oh, I'm telling you, it's going to be the cloud people. They are going to do it. And as I said, I don't expect it too far off. I expect it right after 2.16, there will be some bleeding edge people who try it. The LTS release is when I expect all hell to break loose, and I will be going through tickets crying. That's when I really expect it. Yeah. Oh, and I do want to I think the bigger use is going to be ID. Once we support GUID, I think that is going to be the real push. And I'll make a lot of friends. Yeah, I think that's the big one.
Hey, James. So based on kind of the core functionality and additional work completed in 2.17, in your advice, do you anticipate that the community should at least wait till 2.17 to start using IPv6 in production? And is there any risk some of these targets for 2.17 might slip?
The answer to the second one is no. I don't expect it to slip. That I'm actually confident about. The bulk of the work is done. And as I pointed out, like the one big thing is the net mask handling. That covers a lot of stuff. So like once that piece, a good chunk of what's missing goes in, then the next piece is the GSS work. And I think Sebastian will be working with me on that, of course, because a lot of people will be interested in that. And the first part of your question was, I'm trying to remember, sorry, because I was thinking about that one.
Needed to use IPv6 in production based on the work that's kind of twofold between the two releases?
It depends on what you do in your system. I think for the average user who doesn't use GSS or node mode extensively, like at our lab, we could deploy IP version 6 at 2.16 release. But if you're doing more like node map, and in fact, like I said, if node map, if we complete the net mask handling properly, that node map would completely work. Change logs is expected to work. So it's really like GSS key and some of the NRS stuff. If you do fancy rules for that, like filtering on the NIDs, that's not complete. But I could see that being complete too. Honestly, I can see a lot of completion. You know, I pump out 1 or 2 patches a week on this stuff. But GSS is I think the one. And LNet self-test. I just have to find time to work on LNet self-test.
James, can we see slide 6, Alex Koilasov, Urban?
Which one is that?
So that mount string and output of LNet cattle, they will be like very difficult to read. So may I ask to do some representation in printout, in logs, in mount, and in LCattle output, so admins can easily understand and correlate different NIDs. So it's not IPv6 problem. Once you implement InfiniBand GID, it will be long string, and it is some huge decimal in KFI NID. So it's general for how we represent NID for administrators.
I see what you're. So, are you asking me to present it in a different format?
Maybe if I can specify that when you see such and such NID, print for administrator, like node name and HSN interface name. So some representation which can be externally defined. Because as we discussed, it's even possible to have different representations for the same NID. And that will be very complex.
I see what you're saying, but what would you like to see? Exactly. Like what format would you like to see?
I do not know. It's up to discussion. It's up to discussion. There will be different opinions. But for instance, if you can put the node name and interface, but someone can object that it's different. But NID is unique.
Yes, it is unique.
Yeah, and the problem with multi-rail, right now it's named by primary ID, but when node goes down, there is discovery and different NID becomes primary. And today morning, I saw this report in the log, and in the evening, I see completely different string, not related.
Right, I know what you're talking about.
And it's a big pain.
Yeah.
Does anyone else have a question? Let's get another round of applause for James.